Welcome back everybody to my MATLAB course. Last lecture what we were doing is I drew out how colon notation works and I put the brakes on matrices and arrays. And today what I'm going to do is I'm going to let go of the brakes and we're going to go full steam with matrices and arrays along with colon notation. So we take a look at MATLAB, okay, and I've already created my script file. If you don't know how to create a script file, shame on you by this time. No, I'm just kidding. If you don't know how to create your script file, you can go back to maybe 2 lectures ago or 3 when I was introducing MATLAB, and you can take a look at how to create your script file there. Let's create a real simple matrix. So I'm going to say A is equal to 1, 2, 3, 4. Okay, as I told you in the previous lecture, the semicolon inside these brackets here indicate that there is a row, right? So if I run this, you know that the semicolon is going to suppress this semicolon right here. And now what I want to do is just print out A, and you see that this is my first row and this will be my second row over here. Okay, now we have the ability to access any individual value inside this matrix, and for me to do that I'm going to introduce another keyword called disp so I can show you and print out instead of printing it in the command line. So in my script what I can do is I'll just set a temp variable here. We'll call it temp, and we'll say that A 2 and let's do 1. Okay, so what do you think that's going to do? Well, when we use this row column notation here, what we're doing is we are specifying to MATLAB that we want to access the second row and the first column. So if we look over here, this is row 1 and this is row 2. Okay, row 1 is not what we're looking for here, right? We're looking for row 2, right? So row 2 is right here, and then column 1 is this column right here. So what you would see is we're only accessing an individual value, which is value 3. Okay, so what I'm going to do is I'm going to use disp, okay, and print that out. So now we have the ability to print out data. So see that? I was able to print out the value 3 from our matrix. So that's pretty easy, right? We can also set values inside a matrix. So let's say I want to replace one of the values inside here. Let's print it out again so you can see a visual. Let's say I want to replace this value over here. Okay, we can reference it by using the row column notation, except we're going to do the opposite. Okay, so what we can do is we can say A of, what row are we at? We're actually in row 2. And what column are we at? We're in column 1, right? And then we can say, let's replace it with 10. Okay, now if I disp out my matrix here, you're going to see that it's going to be 1, 2, 3, and 10. So I'm able to write and I'm able to read. Sorry, the value that we replace is row 2. This is row 2, and then column 1 is here. I'm sorry. I forget always. Remember, in MATLAB, rows start at 1 and columns start at 1. So I got a little confused because I thought that this was column 0. But yeah, rows start at 1 and columns start at 1. So in this particular case, the row is 2, right? So we did that. And then column is 1, which is this thing over here. Okay, over here. Okay, the 1 and the 3. So pretty easy. It's not too bad. Okay, let's go into adding values in a matrix. Okay, so if we have, let me get rid of this. Let's say we had a C variable and we're going to add a plus 2. A plus 2. And what that's going to give you, so if I print out C, is, let me run that. It's going to add every single value with the scalar 2. So think of it where you'll have a scalar value, and for every single element in my matrix, it's going to add 2. So 2 plus 1 is 3, right? Then 2 plus 2 is 4, 2 plus 3 is 5, and 2 plus 4 is 6. So what I'm doing here is I'm adding a scalar and a matrix, and that's okay. And then the resulting structure that you're going to get is a matrix. Okay, you're going to get a matrix. Now we could also add matrices together. So let's say we had B is equal to 3, 4, or we could say 5, 6, 7, 8. And I want to say A plus B. Okay, if I run that, it's gonna do every single value in the matrix and add it together. Where you're gonna have each individual element. So 5 plus 1 is 6. Then you have 6 plus 2 is 8. Then 7 plus 3 is 10. And 8 plus 4 is 12. Okay, I think if I show you in a better drawing, this would make a lot more sense. So let's go into our little pad, and I can show you. So stay tuned. Hold on a second. All right, so now we're here with our whiteboard, and what I'm going to do is I'm going to draw the matrices that we had. So let's say we have let's see. Let me erase that. So you have A, right? And we have the matrix 1, 0 and 2, 4. Okay. Plus we have B. So we have the matrix 5, 9. And 2, 1. What we're doing is when we're adding the matrices together is we are going to add element by element, as I said before. So if we look at the first row, first column, which are these and this one, right? So what's 1 plus 5? Well, 1 plus 5 is 6. And we're done with that. Okay, so we can do this, we can do that. Then the next element is going to be row 1, column 2. Right, 0 and 9. Okay, so 0 plus 9 is going to give you 9. Okay, so then we're done with that. Then we go over here and we say 2 plus 2, that's row 2, column 1. So 2 plus 2 is 4. And we're done with that. Okay, and then we have 1 and 4. 4 plus 1 is 5. And we're done with that. And then that's how you end up with the matrix C equals 6, 9, and 4, 5. Simple enough, right?